The world is in a crisis, and we have to save it.
8 million metric tons is the amount of plastic we dump into our oceans every year.
That is equivalent to 57,000 blue whales. And by 2050, it is predicted that the ocean's plastic would outweigh all the ocean fish. In fact, it has ended up creating an island of garbage twice the size of Texas. There, the number of floating plastic pieces outnumber total marine life, 6 to 1. To combat this atrocity, there are several techniques such as 3 R's: reduce, reuse, and recycle. We can go to the extent of filtering out the already dumped plastic in our water bodies. But what if you don't see the plastic at all? Plastic does not degrade. Instead, it breaks down progressively into smaller pieces, but it never disappears. And this gives rise to microplastics. Microplastics are any kind of plastic that measure 5 mm or less, either broken up from larger pieces or manufactured. They can even be unseen to the naked eye. And to say, microplastics don't just float about harmlessly, they have infiltrated the Earth's ecosystem, largely by being accidentally ingested or mistaken for food. It is being eaten by organisms like zooplankton, and a fish ingests that zooplankton. As it makes travel between oceanic zones, other animals that eat it are now inheritors of a microplastic, which we may buy for consumption. It is studied that 1 out of every 3 fish in the market have plastics. In 2014, an estimated 15 to 51 trillion microplastic particles were floating in the world's ocean. It is a shock to know that every single piece of plastic ever made still exists and will continue existing for at least 500 years. So now, when we are aware of its contagiousness, we ought to find a solution. In this project, I'm going to explain a relatively new technology that can efficiently remove microplastics from seawater.
I have collected some sample of water from the ocean. Now we are going to test for microplastics.
I have filtered the seawater to remove the larger impurities such as sand, and I am going to add it to the container. Because microplastic can be extremely small to see with the naked eye, I have created some visible microplastic which are less than 5 mm by cutting down larger plastics. This is done to testify my results. Now I'm going to add these microplastics into my seawater to form a microplastic suspension. As we know, plastics are non-polar substances, and oil is also a non-polar substance. So in chemistry, non-polar substances and non-polar substances attract. So to put that in context, if I add oil to this suspension, the oil will get attracted to the microplastic solution. So now let's test that. I'm going to add the oil into the suspension. The microplastic is starting to get engulfed into the oil. As you can see, after some time, it gets engulfed on its own. But this brings us to another problem. We can't just keep adding oil to our seas. Now, we must find a solution how to remove the oil with the microplastic. And this brings us to ferrofluids. A ferrofluid is any liquid that is magnetic in nature. To create a ferrofluid, we can add oil to magnetite. But on an experiment basis, magnetite is very expensive and difficult to obtain. So for my experiment, we are going to use the dust of TNT sparklers. And to show that this dust is magnetic, I'm going to use a magnet. Now we can see that as I move, it forms interesting shapes here, and it is also being attracted towards the magnet. Now to create my ferrofluid, I'm going to use vegetable oil and my dust. So I'm going to add both of these to a container. And I can stir this to form a sludge. It may not be as thick as it might be in pure magnetite. And now I'm going to create a new suspension of microplastics. Now we are going to add the magnetite. So let me first stir this. Now we are going to add our ferrofluid. As you can see, the microplastics are getting attracted to the ferrofluid. Now to remove the ferrofluid, we can use a magnet. So now you can see that the microplastic has come with the sludge, which is the ferrofluid. Mathematically, we have been able to remove 86% of all the microplastic in that solution. How do we perform this experiment on a large scale? We could first create our ferrofluids using motor oil and magnetite. This would be relatively cheap. Then we could carry it using ships and pour it into the ocean and then leave it for some time. This will attract all the microplastics in the ocean. We could then use a strong electromagnet to remove the ferrofluid with the microplastics. And hopefully our oceans will become clean and free from microplastics. This is Shriman Jha from grade 10 IGCSE, DPS International. Thank you.